Welcome back to the class. Today we'll discuss about the video 3 from the same chapter Shampoos. Very good morning to one and all. So this is the program 4th year BSc Chemistry course Chemistry of Consumer Products topic Shampoos video 3. Department of Chemistry, College of Natural and Computational Sciences, University of Kabridahar, Somali region, Ethiopia. So the resource person is myself, Dr. Mediti Rajshekar, MSc Chemistry, MPhil Chemistry, PhD Chemistry, Associate Professor, University of Kabridahar. So this we can see the picture, different types of shampoos with different colors, maybe in a combination of conditioning also. We can see the picture. So coming to the topics now. Today's topics will discuss about the raw materials for shampoo. The main ingredients for shampoo includes various raw materials as ingredients that we'll discuss about the water, detergents and surfactants, foam boosters and stabilizers, conditioning agents, viscosity modifiers, including hydrocolloids and electrolytes, opacifiers or clarifying agents, sequestering agents, preservatives, fragrances and colors, special additives, including anti-dandruff agents, and other one is sodium lauryl sulfate, LSL, or sodium dodecyl sulfate, its preparation and reaction mechanism, and finally sodium lauryl sulfate, its preparation and reaction mechanism. This is about the contents, today's topics. So let us start the first topic, raw materials for shampoos. Actually, the main purpose of shampoo preparation or manufacturing is to safeguard the hair. A shampoo basically a solution of a detergent modified by additives to render an easier application and to safeguard against deterioration of the hair condition after the shampoo has been rinsed away. So the main purpose of shampoo is to protect the hair from all the atmospheric conditions along with cleaning. So from the first ingredient we'll see about that is water. Water is a universal solvent as we know. Water plays a very important role for the existence of life. Water is not only useful for living beings, for also preparation of manufacturing of various non-living things. Also, we can see in this point of view, shampoos concept, water plays very important role for the dilution and minimizing frothing. Water is meant for to dilute the concentration of the shampoo containing the different ingredients, and also it minimizes the frothing. Water is a primary ingredient in all shampoo. It makes about 70 to 80% of entire formula and inexpensive, minimizes frothing with surfactant. So this is about the main thing. 70 to 80% of the shampoo is consisting of water because it minimizes the frothing bubble formation and also it is less expensive. It helps to dilute the detergents and make the formulation easier to spread and reduce the irritation. And also the dilution will be increased in the shampoo, spreading of the shampoo overall the head and the hair, and also reduces the irritation. This is about the importance of water, and also it acts as a foam booster. Contain N-alkyl betaine is a foam booster, we can say, and other functional ingredients are mixed by proper stirring. Along with this, to maintain the foam, the pH adjusters, citric acid may be added, and thickness are added with vigorous stirring. So citric acid may be also added to maintain the pH sometimes, and preservatives and perfumes are also added at the last step after having the proper composition of water. Second one is surfactants. Surfactants basically used in the shampoo manufacturing are non-ionic surfactants, cationic surfactants, anionic surfactants, amphoteric surfactants. Coming to the non-ionic surfactants, it is of moderate use because the non-ionic detergents or surfactants have cleansing power but less foaming property. Cleansing power is good, but foam formation is lesser, so it is moderately used. So not used as a principal foaming agent. It can be used moderately. They are mild and non-irritating to skin and are also used as foam boosters and stabilizers. This is not that much irritating and it is used in a moderate way. Coming to the second one, that is cationic detergents. These are not much in use because it produces foam well and have sufficient cleansing power also. Leaves the hair lustrous and free of alprestory charges. But the drawbacks are weigh downs the hair. The weight of the hair will be decreases, and also it may causes the injurious effect to the eye tissue, corneal eye tissue. So next one is anionic surfactants. These are cheaper and not that much used well. So due to their superior foaming property and low cost are not widely used surfactants. It has a more foaming property but cheaper. And ampholites containing both acidic and basic nature are used for their hair conditioning properties. So examples of surfactants used in shampoos includes coming to the anionic surfactants includes alkyl benzene sulfonates, alkyl sulfates, acyl peptides, sulfosuccinates, acyl lactylates, alkyl polyethylene sulfates, etc. Non-ionic surfactants includes fatty acids, alkanolamides, example monoalkanolamides, polyalkyl alkylated derivatives, and amine oxides, etc. Amphoteric surfactants comprises of examples N-alkyl amino acids, that is beta amino acid derivatives and betaine, etc. These are about the surfactants that are used in the shampoo. Third point is foam boosters and stabilizers. Increases the viscosity, lather, and the conditioning effect to the hair. Foam boosters and stabilizers generally increases the viscosity and also lather, also brings the good conditioning effect to the hair. Foam boosters or foam stabilizers, when added to formulations, increase the quantity, volume, and stability of lather. So this is very important property we can say. And often they also increases viscosity and impart slight conditioned effect to the hair. The principal foam boosters examples may be are the fatty acid alkanolamides such as lauryl diethanolamide fatty alcohols with low concentrations, and to small extent phosphates, dodecyl benzene sulfonate is considered as a good foaming surfactant when used alone. So the addition of lauryl monoethanolamide not only increases the initial foam volume but also enhances the stability of the foam. So this is about the we can see the foam boosters and stabilizers, different examples. And fourth one is conditioning agents. The main concept of conditioning agents is cleanses the hair, conditions and manages the hair. Second point, improves the feel, softness and static charge. This is about the property of the conditioning agents. So some materials are added to the shampoo to offset the harsh effect of surfactants. Whenever the hair is washed with the shampoo containing the surfactants, that may impact the harshness or may affect the hair to become harsh. Typical conditioning agents includes polymers, silicones, fatty materials like lanolin and its derivatives, herbal extracts, and synthetic products, that is surfactants, etc., may be used as an agents that brings out the conditioning effect. Conditioning agents are intended to improve the manageability, feel, and luster of the hair. So this is also very important point. Manageability, hair becomes manageable. You get the feel that it is completely cleansed with, and also it is in good condition as far as its health is concerned. These ingredients are left on the hair surface, rinsing, and they modify the characteristics such as feel, softness, compatibility, and static charge. So, shampoos which specifically feature conditioning as a benefit are called two-in-one shampoos. They clean and condition hair in the same step. So, we can see the shampoos are of two types called as two-in-one shampoo. That is, which cleanses the hair and also which makes the hair to be conditioned. So, they are called as two-in-one shampoos. Examples of conditioning agents including hydroxy propyl chloride, which is a polymer, dimethicone, which is a silicone, and quaternium 80, a quaternary agents, are some of the examples of the conditioning agents that are frequently used. Fifth one is viscosity modifiers. Viscosity modifiers means the shampoo quality and its quantity also depends upon the thickness or viscosity of the shampoo. So viscosity modifiers are those which thickens the shampoo, makes the shampoo to become thick. So examples, gums and salts are also added to increase the thickness of the shampoo. They are used for thickening of shampoos. In general, natural gums such as gum called as kara, Takakant, gum acacia have been replaced by synthetic gums such as hydroxyl ethyl cellulose, methyl cellulose, carboxymethyl cellulose, and carboxyvinyl polymers. All these are examples of synthetic gums. But care must be taken since they have tendency to form films on the hair. When these gums are used after cleansing the hair, they may form some films on the hair. So we have to take care of the hair after finishing the hair wash. Simply adding salt also, we can increase the thickness of the shampoo. Some inorganic salts and electrolytes such as sodium and potassium chloride can also be used in limited amounts to bring the thickness to the shampoo. However, the difficulty of film formation is avoided by using other thickening agents such as alkanolamides and glycol or glycol stearates. Sixth point is opacifiers and clarifying agents. So these opacifiers and the clarifying agents, so the main purpose of this is provides the transparency. Some shampoos are, when you see, they are very transparent, like water. So transparency can be increased by adding these opacifiers and clarifying agents. In general, coupling and solubilizing agents helps to maintain shampoo clear over a wide range of temperatures. Care must be taken in selection of compounds of this type for possible eye irritation and toxicity. Even though some of the shampoos may be very transparent, but some are toxic, we have to check the presence of ingredients present in the shampoo. Suppose if they are causing any irritation to the eye or toxicity, we have to avoid that one. Transparency may be improved by solubilizing alcohols, phosphates, or non-ionic solubilizers. Opacifying agents, coming to the point of opacifying agents, means it includes the examples of alkanolamides, of higher fatty acids, glycol monostearates, and distearates, propylene glycol, and glycerol monostearates, fatty alcohols, example, that is cetyl alcohol, stearyl alcohol, and milky emulsions of vinyl polymers, and latexes, insoluble salts consisting of magnesium, calcium, or zinc sulfate, salts of stearic acid, and finally dispersed zinc oxide or titanium dioxide and magnesium aluminum silicates, etc., are some of the alkanolamides may be used uh, to some extent. And clarifying agents, it includes solubilizing alcohols like ethanol, isopropanol, propylene glycol, ethylene glycol, etc. And the phosphates are non-ionic stabilizers like polyethoxylated alcohols and esters also belongs to this category. So these are some of the examples of the opacifying agents and clarifying agents that are used based on the requirement. Seventh point is sequestering agents. The purpose of these sequestering agents is avoid salt deposition on the hair. Sometimes when the water is not good, maybe containing more amount of salts, that salts will be deposited on the hair after cleaning the hair with shampoo also sometimes. The addition of 1% of sequestering agents such as citric acid and salts of EDTA prevents the lime soap formation on the hair. This is one important point regarding sequestering agents. Non-ionics in low concentrations improves the cleansing action of soaps, and polyphosphates such as tetrasodium pyrophosphates, tripolyphosphates possesses good clarifying action. These salts decreases solubility of soaps and detergents. So salts can be removed. Depositions of salts can be removed by adding the very minute percentage of sequestering agents. Preservatives. So this is also very important for the shampoo. Sometimes shampoo may undergo some decomposition and bacterial effect. So preservatives are those which nullifies bacterial growth. Bacterial growth in shampoo can lead to breakdown and discoloration of the product. Surfactants in shampoo tend to interfere with the bacterial activity of the antibacterials. So therefore, higher concentrations of the preservatives are needed like formaldehyde, ethanol, methyl, propyl and butyl hydroxybenzoate, phenyl mercuric acetate, the alkyl anisole, etc. Some of the preservatives that can be used to decrease the bacterial growth in the shampoos. The most common ingredients used in shampoos, two most important ingredients used in shampoo are DMDM hydantoin, dimethyl dimethyl hydantoin, releases formaldehyde and is compatible with most surfactants. And the second one is methylparaben. So these are some of the ingredients that are used. Coming to the ninth point, fragrances and colors. This is also very important because color attracts the uh, customers to buy the shampoo. Color also very important factor, and fragrance is very important. The smell, the aroma of the shampoo also costs a lot. So needed but not affect the shampoo. Fragrances and coloring agents may be added, but that should not affect the quality, the quantity of the shampoo. All shampoos have perfume essential oils, and dyes in them. So fragrances should not affect the viscosity and stability of the shampoo. So the perfume, different perfume, different aroma of the shampoo is very much needed, and that should not affect the viscosity and the stability of the shampoo. Special additives: selenium sulfide, zinc pyrithione, pyrophthaleolamine, the iodine-containing hydroxyquinolines, and some quaternary ammonium compounds. These are the special additives generally present. These can be added based on the requirement. We can see different special additives and their use, up to what extent they can be handled. First point, anti-dandruff compounds, if we see sulfur, salicylic acid, hexachloroprene, resorcinol, and tar. And stabilizers may be added, that is, antioxidants, sunscreens, suspended agents, and pH controlling agents called as stabilizers. And UV protection is very much needed, that is, a benzophenone or benzotriazole derivatives absorbs harmful ultraviolet radiations. Suspended agents protects the shampoo. Maybe also added Begum and bentonides stabilize the shampoo, protects the shampoo from the atmospheric effect, and reducing agents protects the product from discoloration and bad odor due to oxidation. So these are the very important special additives that are added. Coming to the another important point of view in this class, that is preparation, or knowing about the sodium lauryl sulfate or sodium dodecyl sulfate. So this is a shampoo. We'll see its preparation and the reaction mechanism. Sodium lauryl sulfate is an anionic surfactant that is used in household products such as toothpaste, shampoos, shaving foams, some dissolvable aspirins, fiber therapy tablets, and bubble baths for its thickening effect and its ability to create a lather. This is about the usage, the requirement of the this type of shampoo. So the molecule has a tail of 12 carbon atoms. Sodium dodecyl sulfate has the 12 carbon atoms attached to a sulfate group, giving the molecule having the properties of amphiphilic in nature. It's like a detergent. So let us see the preparation now. Very simple preparation. Sodium lauryl sulfate is prepared by esterification of sulfuric acid with dodecanol, that is lauryl alcohol, C12H25OH, followed by neutralization with sodium hydroxide. It is used to in both industrially produced and homemade cosmetics. So first of all, the preparation, it constitutes the esterification of sulfuric acid with lauryl alcohol, followed by neutralization with sodium hydroxide. That is the preparation to understand. And let us see the steps. There are two steps are there. First one is sulfation step. Second one is neutralization step. In the sulfation step, the lauryl alcohol plus sulfur trioxide forms lauryl alcohol sulfate. So that is the first step, that is the sulfation reaction step. That is C12H26O4 plus SO3 gives C12H26SO4, and it forms the product called as the lauryl alcohol sulfate. And the second step is neutralization. Here it is undergoing neutralization by sodium hydroxide, that is lauryl alcohol sulfate, which is formed in the sulfation step 1, reacts with sodium hydroxide, producing sodium lauryl sulfate. C12H26O4 plus NaOH gives C12H26SO4Na. This is about the sodium lauryl sulfate preparation. Reaction mechanism involves in a simple manner to understand by means of two sentences. Sulfur trioxide reacts with lauryl alcohol, forming sulfate group. That is the step 1. Step 2 is sulfate group, which is formed, then neutralized by the sodium hydroxide, forming sodium lauryl sulfate. That is the preparation and mechanism of the sodium lauryl sulfate. Reaction conditions, we can see temperature will be around 100 to 150 degrees centigrade. Pressure will be at atmospheric pressure only. Catalyst, none or ST catalyst may be used. Reaction time will be around 2 to 5 hours. Applications of sodium lauryl sulfate. Sodium lauryl sulfate is probably the most researched anionic surfactant compound. Like all detergent surfactants, including soaps also, sodium lauryl sulfate removes oils from the skin and can cause skin and eye irritation sometimes. It has been recently found application as a surfactant in gas hydrate or methane hydrate formation reactions, increasing the rate of formation as much as 700 times. This is about the application. And next one is sodium lauryl sulfate. SLE is sodium lauryl sulfate, or it can be also called as sodium lauryl ether sulfate. It is accepted contraction of sodium lauryl ether sulfate (SLES), also called sodium alkyl ether sulfate, is an anionic detergent and surfactant also found in many personal care products, including shampoos, soaps, toothpaste, etc. And for industrial uses also, SLES is an inexpensive and very effective foaming agent. And sodium lauryl sulfate, ammonium lauryl sulfate, sodium ferrous sulfate are all surfactants. They are used in many cosmetic products for their cleaning and emulsifying properties. It is derived from palm kernel oil or coconut oil. This is about the information about the sodium lauryl sulfate. Now let us see the preparation and the reaction mechanism. So preparation of sodium lauryl sulfate. SLAS is prepared through ethoxylation of lauryl alcohol followed by sulfation and neutralization. It involves three different steps we can see: ethoxylation, sulfation, and neutralization. Step one, it forms into the step one is ethoxylation. What will be done in this ethoxylation means lauryl alcohol plus ethylene oxide produces lauryl alcohol ethoxylate. C12H26O plus C2H4O forms C12H26O, CH2CH2O, N times H. That is ethoxylation reaction. And sulfation. Lauryl alcohol ethoxylate, which is formed in step 1, reacts with sulfur trioxide, forming lauryl alcohol ethoxylate sulfate. That is C12H26O, CH2CH2O, N times H plus SO3. It forms C12H26O, CH2CH2O, N times SO3H. This is about the sulfation reaction step. And the third one is neutralization. Lauryl alcohol ethoxylate sulfate, which is formed in the step 2, now reacts with sodium hydroxide as a neutralization process. It forms sodium lauryl ether sulfate, that is C12H26O, CH2CH2O, N times SO3H plus NaOH gives rise to C12H26O, CH2CH2O, N times SO3Na. This is about the sodium lauryl sulfate preparation and its reaction mechanism. Now, the reaction mechanism simply to understand in three steps. Step one is ethylene oxide adds to lauryl alcohol, forming ethoxylate. Sulfur trioxide reacts with ethoxylate, forming sulfate group. Step three, sodium hydroxide neutralizes the sulfate group, forming SLES, sodium lauryl ether sulfate. Coming to the safety measures, tests in the US indicate that it is safe for consumer use. The Australian Government, Department of Health and Aging, and its National Industrial Chemicals Notification and Assessment Scheme have determined that SLES does not react with DNA. So there is no problem in using of this SLES. So coming to the irritation, of course, all the products have their own limitations regarding the irritation and some other allergic effects. So coming to the irritation point of view here, like many other detergents, SLES is an irritant. It has been shown that SLES causes eye or skin irritation in experiments conducted on animals and humans. The related surfactant SLES is also known as irritant. And the last point of view is 1,4-dioxane contamination. This is very important to understand. The products containing sodium lauryl ether sulfate can be contaminated with up to 300 ppm of 1,4-dioxane, a byproduct of SLES production. The 1,4-dioxane is classified by the International Agency for Research on Cancer as a group 2B carcinogen, possibly carcinogenic to human beings. So, the United States Food and Drug Administration recommended that those levels be monitored and encourages manufacturers to remove this 1,4-dioxane, though it is not required by federal law. So, the byproduct which is obtained in the preparation of sodium lauryl ether sulfate, that is 1,4-dioxane, is carcinogenic in nature. Therefore, the FDA recommends to avoid this, to eliminate this product formation of 1,4-dioxane, as it is very much carcinogenic. So this is about the today's class, and we have discussed about the three videos from this shampoos from the chemistry of consumer products. So if you want to refer the other two videos, you can refer the all the three videos in the same channel. Thank you so much.